Something strange is happening in deep space right now, and astronomers can't look away. An object from another star system, known as 3I Atlas, is tearing through our solar system at nearly 60 kilometers per second. It's not just passing through quietly. In the last few weeks, it has grown a massive green halo, brighter and bigger than models ever predicted. Instead of fading into the background like most comets at this distance, 3I Atlas is putting on a show, doubling its brightness faster than anyone expected, and building a coma so huge it now rivals the size of Jupiter. Telescopes on Earth are scrambling to keep up, and some scientists are quietly asking if we're seeing normal cometary activity or something we've never witnessed before. With its closest approach to the sun still ahead, and Earth's window to watch it quickly closing, the race is on to capture every last detail. What is inside that green cloud? What's driving this explosive surge in activity? And could this interstellar visitor rewrite everything we thought we knew about comets? 3I Atlas first appeared on astronomers' radar in early July 2025 when the Atlas Survey telescope in Chile flagged a faint, fast-moving object. At first, it looked like any other new comet, but when orbital calculations came back, jaws dropped. This thing was not bound to the sun at all. Its trajectory was hyperbolic, meaning it came from interstellar space and would never return. It instantly became just the third interstellar object ever discovered after Oumuamua in 2017 and 2I Borisov in 2019. Unlike those earlier visitors, 3I Atlas is traveling much faster and showing far more activity. Right now, it's roughly 2 astronomical units from the sun, about 300 million kilometers away, yet already racing along at nearly 60 kilometers per second. That's twice as fast as any planet in the solar system and fast enough to cross the Earth-Moon distance in barely over an hour, and it's still accelerating. Its orbit takes it on a steep dive toward the inner solar system, swinging closest to the sun at the end of October. From there, it will slingshot back into interstellar space, never to be seen again. That gives astronomers just a few short weeks to collect as much data as possible before it disappears into the black. What's remarkable is how early it became active. Most comets wait until they're much closer to the sun before putting on a display, but 3I Atlas started venting gas and dust far beyond Mars's orbit, a sign that its ices may be unusually volatile or that its surface has never been warmed before. Either way, this is no ordinary comet, and the strangest part? The farther it comes, the more dramatic it gets, setting the stage for a mystery no one expected.
The first thing anyone notices about 3I Atlas is its glow. Not just bright, but green. That eerie color isn't just for show. When astronomers aimed spectrographs at the comet, they found its coma packed with carbon-based molecules, including diatomic carbon, or C2. When sunlight strikes these molecules, they light up in a vivid green, creating a halo hundreds of thousands of kilometers across. But that's only part of the puzzle. Data from the James Webb Space Telescope shocked researchers. 3I Atlas is releasing carbon dioxide in record amounts, far more than we see in most solar system comets. In fact, the ratio of CO2 to water is one of the highest ever measured. That means something deep inside this comet is unusually rich in frozen CO2, or dry ice, and it's being blasted into space at an incredible rate. Even stranger, early spectra hinted at traces of cyanogen and ionized carbon monoxide, both of which can glow green or blue under solar radiation. The combination could explain why this comet's coma looks so intense, almost electric, even from more than 300 million kilometers away. For astronomers, this chemical cocktail raises big questions. Was 3I Atlas formed in a frigid outer disk of another star system where CO2 could stay frozen for billions of years? Or is its surface so pristine that sunlight is unlocking materials no comet from our solar system still carries? Whatever the answer, the green cloud is more than just a pretty sight. It's a window into the comet's origins and perhaps into the chemistry of worlds beyond our own. But the glow isn't the only thing that has scientists puzzled. The comet's brightness itself is behaving in ways no one predicted, and what comes next could rewrite the rules of comet science.
For weeks, astronomers thought they knew what to expect from 3I Atlas. The models were clear, a slow, steady rise in brightness as it drew closer to the sun. But in mid-September, those predictions fell apart. The comet's light curve, the graph astronomers use to track how an object brightens over time, suddenly spiked. Instead of following its projected path, 3I Atlas jumped to nearly 6 times the expected brightness, leaving even veteran comet watchers stunned. This wasn't just a slow, gradual drift, it was a surge, the kind that usually signals something dramatic is happening near the nucleus. The coma, that vast cloud of gas and dust, exploded outward, growing to a size rivaling Jupiter itself. More surface area meant more sunlight was being scattered back toward Earth, turning the whole comet into a cosmic reflector. But what triggered it? Some astronomers suspect sunlight hit a pocket of volatile ice, blowing open a fresh vent and sending a geyser of material into space. Others think the comet might be spinning fast enough to shed dust in pulses, briefly boosting its brightness. A few even whisper about more exotic explanations, from buried reservoirs of rare ices to completely new processes we've never observed before. And as if that wasn't enough, observers have reported a faint sunward spike, an anti-tail, pointing back toward the sun. Normally, a comet's dust tail streams away from the sun under the push of solar radiation. Seeing a tail appear in the opposite direction is rare, and it suggests 3I Atlas is ejecting unusually large or electrically charged particles that aren't behaving like ordinary dust. Every new night of data just deepens the mystery, but the window to solve it is closing fast.
Time is running out to watch this interstellar visitor from Earth. Each evening, 3I Atlas sinks lower in the twilight sky, creeping closer to the sun's glare. By late October, its solar elongation, the angle between the comet and the sun in our sky, drops below 30 degrees. That's the danger zone, where even the largest ground-based telescopes struggle to separate its faint light from the blinding glow of sunset. For professional observatories, that's the point where safety protocols kick in. Pointing billion-dollar optics too close to the sun risks burning detectors, so many facilities have already begun winding down their comet campaigns. For amateur astronomers, the challenges are even tougher, with just minutes of dark sky after sunset to catch a glimpse, and only if weather cooperates. Once 3I Atlas passes behind the sun from Earth's point of view, we enter a data blackout. No direct spectra, no images, no way to measure its brightness or track any new outbursts. And that's when it will be at its most active, closest to the sun, and potentially most spectacular. But there is one place that will still have a front row seat: Mars. On October 3rd, 3I Atlas sweeps within about 28 million kilometers of the red planet, close enough for a fleet of orbiters to turn their cameras and instruments toward it. ESA's Mars Express can capture stereo images and analyze the coma's chemistry. The Trace Gas Orbiter can sniff out faint emissions of CO2, water, and exotic gases. NASA's MAVEN mission can track how the solar wind slams into this alien visitor, while the Mars Reconnaissance Orbiter may even be able to spot the nucleus itself if conditions line up perfectly. For weeks, mission teams have been running simulations and fine-tuning observation plans, racing to secure every possible viewing slot. Even a few successful passes could reveal details we could never get from Earth: direct measurements of dust, gas production, and the comet's reaction to the solar wind on a scale never attempted for an interstellar object. It's a rare moment where an entire planet becomes humanity's eyes on the cosmos, and if those spacecraft succeed, they might answer some of the biggest questions about what's really happening inside that glowing green coma. Even as 3I Atlas slips out of sight from Earth, the real drama is still ahead. Its perihelion, the closest point to the sun, is coming soon, and no one knows exactly what will happen next. Some comets break apart under the sun's heat, shattering into dozens of glowing fragments that scatter across space. Others survive the encounter and erupt into even more spectacular displays as the heat drives off their most volatile ices. For an interstellar comet like 3I Atlas, there is no playbook. This is only the third time in history we've seen an object from another star system up close, and the first time we've had modern space telescopes watching every step. If it survives perihelion intact, it could flare dramatically on its way back out, becoming visible again in early 2026, this time as a fading ghost in the dawn sky. If it doesn't, the final data from Mars orbiters may be the only record we ever have of its nucleus before it vanishes forever into the black. But perhaps the biggest questions are the ones scientists can't answer yet. Where exactly did 3I Atlas come from? Is its unusual chemical mix common in other star systems? Or is this a 1 in a billion object? Could these interstellar travelers be carrying clues, maybe even building blocks of life from one star to another? Each new observation brings us closer to answers, but also reminds us how little we know. Whatever happens at perihelion, this comet is giving us a once-in-a-generation chance to peer into the chemistry of a completely different solar system, and possibly into the very processes that shaped our own. And with astronomers already scanning the skies for the next interstellar visitor, the story of 3I Atlas might just be the opening chapter of something much bigger.
Right now, 3I Atlas is out there, racing past Mars and plunging toward the sun, a silent messenger from another star. Every hour brings it closer to the moment of truth, and every telescope on Earth and Mars is fighting to capture its secrets before it's gone for good. Whether it survives, explodes, or fades quietly into the void, this object is rewriting what we know about comets, about planetary systems, and about the space between the stars. It's a reminder that our solar system is not an isolated bubble. It's part of a much larger, constantly changing galaxy where travelers like this may be far more common than we ever imagined. The next few weeks could give us answers we've waited decades for, or raise even stranger questions. And if this is just what one interstellar visitor can teach us, imagine what we'll learn from the next.